Sam Altman has asked for trillions of dollars for a new AI chip venture. You heard that correctly, trillions, with the T. This is outlandish and probably not to be taken seriously, but understanding his claim can actually help us understand the role that venture capital plays in reshaping the economy and the world. Sam Altman has a track record of making headline-grabbing statements. He spent much of 2023 telling world governments that AI might one day kill us all. He certainly doesn't have understated visions of the future. So when the Wall Street Journal reports that Altman is in talks with investors about a chip-making project that could require raising as much as $5 trillion to $7 trillion, and we assume that's not a typo, how should we think about a claim like this? OpenAI, like all AI companies, has a supply chain constraint. They are heavily dependent on new, better, faster chips made by companies like Nvidia and TSMC. Even though production of these chips is ramping up, demand still massively outstrips supply. It is a massive challenge, which will need an equally massive solution. This is not unprecedented in history. It's a pattern we've seen in other industries, like electric cars. If everybody is going to be driving electric cars in the future, we will need to massively scale production of electric car batteries. This will take huge sums of money to build many factories and massive supply chains.
But this first plant is going to cost us another $300 or $400 million to build out, right? And that's plant number one for 20,000 tons. And to put things in perspective, about 1,000 tons of graphite produces about a gigawatt hour of batteries. So you start hearing 40 gigawatt hour plants. If those use all graphite, they need about 40,000 tons. So LG has announced 200 gigawatt hours to build in the US. Panasonic has announced 200 gigawatt hours to build in the US. Tesla has talked about going to terawatt hours of scale. So these are million plus tons of demand. And it's taking us this amount of time, this amount of capital to get the first 20,000 tons out of the gate. And that's the scale challenge.
But unlike Sam Altman's project to take on the entire AI chip supply chain himself, no individual car company has tried to take on the battery supply chain challenge alone, even if they could see it coming.
It's one of the reasons you do see so many former Tesla people kind of at the helm of different companies in the supply chain now, because back in, let's say, the 2012 to 2015, 16, 17 era, as Reno was coming online, Tesla was one of the only places you could be in the US that really understood that scale issue, right? And therefore, everybody got to look at some little problem statement, quote unquote, little problem statement like graphite, and it's a huge business opportunity. And so people went out and chased all of these different problems because, kind of to your question earlier, Tesla couldn't play whack-a-mole with that many.
So it would be unusual for Sam Altman to take on the entire AI chip-making supply chain by himself, but it wouldn't be without precedent. As the Industrial Revolution took hold in the US, it was quite normal for some of the larger titans of industry to try to own everything.
From the 1870s onwards, you have the rise of organizations, for example, like Richard Sears' Sears and Roebuck, which creates a huge catalog-based retailing business in Chicago. You have the creation of Andrew Carnegie's steel company introducing mass production into steel, Henry Ford introducing mass production into cars, David Duke into cigarettes. The object of all of these people is to own as much of the production process as possible. So, for example, Henry Ford owned the land on which grazed the sheep, whose wool went into the manufacture of the seats of his cars. And if you didn't actually own everything, your objective was to buy everything.
There was undoubtedly ego and sheer power at play with these early industrial barons, but there was also a recognition that the other actors in their supply chains, like the steel miners or the sheep farmers or the tobacco farms, weren't industrializing as fast as the industry needed them to. If Henry Ford was to produce a car for every family in America, he needed to bend huge parts of the country's economy to act as a supply chain for the production of cars. What would a similar feat take today? Maybe $5 to $7 trillion? Considering that the entire UK GDP is only about $3 trillion, how do we even wrap our heads around figures this big? To start with, we should understand that Sam Altman is talking about credit in the form of venture capital. credit that he would use to take land, natural resources, labour and capital from their current uses and repurpose them towards AI chip production. In 1934, political economist Joseph Schumpeter said that the essential function of credit consists in enabling the entrepreneur to withdraw the goods which he needs from their previous employments by exercising demand for them and thereby force the economic system into new channels. If you're opening a new gym and you get a new business loan, Schumpeter is saying that the credit in the form of a loan lets you rent a premises which might otherwise be rented by a coffee shop or a local mechanic or might have sat idle. It lets you attract staff to give up their previous jobs and lets you pay for all that while you're still getting the new business off the ground. You can place an order for free weights and running machines before you even have revenues. Any AI chip companies will need new specialized machinery in their factories and land to build them on. They'll need silicon and copper and cobalt and tungsten as raw materials to make their chips, and they'll need people as workers to make that all happen. These people are currently working other jobs and need salaries to start working on AI chips. The materials are being used as inputs to other projects, and new chip makers will need to outbid them. Old factories need to be rented and renovated from their previous use, or vacant land needs to be found for the new factories to be constructed. Schumpeter would say that this is what Sam Altman's trillions of dollars really represent. The cost of wages and rent and raw materials that would be needed to divert them from their current use to the scale-up of AI chip making. After the factories and supply chains are up and running, then the revenue from chip sales can fund ongoing costs. The Information's Stephanie Palazzo believes that Sam Altman isn't going the Henry Ford route of owning the entire supply chain, and instead is floating hypotheticals to illustrate the scale of the problem. It's likely that the trillions figure represents the total that will be needed over a multi-year period. Let's imagine, for simplicity's sake, that we're talking about $1 trillion per year for the next decade or so. The World Bank estimates that global GDP was about $100 trillion last year. About 16% of this, or 16 trillion, is in manufacturing. So spending $1 trillion per year could represent reallocating 1 in every 16 workers, or square foot of floor space, or tonnage of raw material towards AI chip manufacturing. Now this is comparing the cost of inputs, the investment needed, with the price of outputs, GDP. And there isn't a one-to-one ratio of worker hours to factory square footage to raw material tonnage, so this comparison isn't perfect, but it is a good enough approximation for assessing a grandiose claim like Altman's, and more importantly, it helps us think about what it would mean to allocate trillions of dollars towards scaling up AI chip production. If the prospect of reallocating 6% of the world's industrial productive capacity to AI chip making seems large to you, well, I'd agree. If that's the size of the task at hand, we might not quite be ready for it. To get there, we'll need lots of productivity improvements, both in the new chip-making industries and in the legacy industries currently employing the workers and the land and the raw materials that it will need. Productivity gains will lower the demand for these resources and let us create more with less. Until then, the big numbers that Sam Altman is floating might actually be correct.